Today we're going to look at solving some different angles and sides of triangles given that the triangles aren't right triangles. And specifically we're going to look at the law of cosines today. Now, given this picture here, if I want to find this value of x, since I don't have a right triangle, I'm going to have to go through a process of doing a whole bunch of operations. Thus, maybe creating a vertical angle here, finding this height because now that's a right triangle. Once I have that height, then I know I can find this side. Once I find this side, I can find this side by subtracting from 20. Once I have these two, I can take a Pythagorean theorem, but that's a lot of work. Now, law of cosines comes from given a side angle side in a specific triangle, which is what we have here, side angle side given, or a side side side, you can use this thing called law of cosines. And what we're going to do is we're going to establish how this came about to start with. So once again, we're going to go through a set of processes given that I have a side angle and a side. So let's say I have AB and the angle C, and I want to find the side C. Well, again, just like I explained in the previous example, we're going to take and find that height. So to do that, I can say the sine of angle C is equal to h over a. And likewise, I can say the cosine of angle C, let's call this x. Cosine of angle C is equal to the adjacent, which is x, over the hypotenuse, which is a. So now I know that h is equal to a sine c, and I know that x is a cosine c. So as we've stated before, I can then find, let's call this y, all right? Y is equal to whatever that b value is minus this x value, which is a cosine c. And I already have h, which is a sine c. Therefore, to get the side c, I can use a Pythagorean theorem and say c squared is equal to h squared plus y squared. But now I can make these substitutions. So h is a squared sine squared c, and y squared, y is going to be a little bit tougher, so I'll put that as a binomial and square it. But I'm going to still expand that, giving me a squared sine squared c plus b squared minus 2ab cosine c plus a squared cosine squared c. So now I'm going to take and notice that I have a squareds in common here. So this is a squared times sine squared c plus cosine squared c plus b squared minus 2ab cosine c. Notice this is 1, so I have a squared plus b squared minus 2ab cosine c. And you may think, so what? Well, basically, I have the a, the b, and the angle c, which was given, and that allows me to find the missing side. And this in itself right here is the law of cosines. Notice what's also going on. This side is opposite this angle, which is given. And then I have the two sides in a Pythagorean relationship minus 2 times the product of those two sides given times the cosine of that opposite angle. So when I go back to that initial problem and I want to find x, I know that x squared is equal to 14 squared plus 20 squared minus 2 times 14 times 20 cosine 22. And that just becomes a giant calculator problem. And so I have x squared equaling about 76.77. So x is equal to the square root of that, which is about 8.76. Now we have three sides and they want us to solve a triangle. This is a little new verbiage for these type of problems, which means find all the missing sides and angles. So if I just sketch this out, and I have, let's go, C is here, so that's 9. B is here, it's 8, and A is here, 7. And we want to find all the missing sides and angles. Usually what I'll do is in a law of cosine situation, I will find the biggest angle first. So in this case, I'll find C, and I have 9 squared equals 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of angle C. So now I have to isolate angle C. To do that, I bring the 7 squared and the 8 squared over, and I divide by this product here, and that's going to equal the cosine of angle C. So then I take the inverse cosine of this quantity here, 9 squared minus 7 squared minus 8 squared over negative 2 times 7 times 8 to get my C value. And that's a calculator problem again. And I get roughly 73 let's go 4 degrees. Now if I know that's 73.4, I can go ahead and do law of cosines again and get either B or A. And like I said, I usually like going in law of cosines with the biggest value. So I would say 8 squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of B, and go through that whole same process. So again, 8 squared minus 7 squared minus 9 squared over negative 2 times 7 times 9. Take the inverse cosine of all that to get me B. And that gets me roughly 58.4 degrees. So then I just take 180 minus 73.4 minus 58.4 to get A, and then I'm done. Next, we want to find the area of a triangle given 3 sides. Now, there's a special formula for this. If we remember back in the day, given 3 sides of a triangle, there's this guy named Huron. And he talked about having 3 sides to a triangle and finding the area. Talked about something called a semi-perimeter. And the semi-perimeter is just half the perimeter. And they call that S. And it turned out that the area was equal to the semi-perimeter times the semi-perimeter minus one side multiplied by the semi-perimeter minus another side minus the semi-perimeter, or multiplied by the semi-perimeter minus that third side. So this is just a plug and chug problem. We know we have 15, the semi-perimeter of 24 over 2, or 12 in this case. So then if I want the area, I take 12 times 12 minus 7 times 12 minus 8 times 12 minus 9. Grind all that out. That's 12 times 5 times 4 times 3. Square root it, and that gives you the area. So a little bit of word problems now. We've got a ship leaving port at 1 o'clock traveling north at a certain speed. So let's just take and draw a picture here. We're going to go north at a certain speed. All right, and then we're going to take and at 3 o'clock they adjust the course on a bearing of north 20 degrees east. So north 20 degrees east puts me somewhere like this over here, where I have this invisible dotted line, if you will, right here, and this angle of 20 degrees here, which puts me in this situation where I have 160 degrees at this angle. And we want to know how far is the ship from port at 4 o'clock. So once again, we left at 1, and then we turned at 3 o'clock, and we were going 30 miles an hour, so I've been traveling 2 hours, so this is 60. And then I want to know how far we're going after 4 p.m., so I've gone 1 more hour, so this is 30. So since I have my side angle in my side, all I have to do is set up, again, the law of cosines and say x squared is equal to 30 squared plus 60 squared minus 2 times 30 times 60 times the cosine of 160 degrees. X at the end after square rooting both sides is roughly 88.79. It's going to be what, miles? In our next example, we want to go from the airport to the Cliffs of Insanity by following a bearing of north 8.2 east. So that's going to be roughly something like this. If here's my X and Y point to start with, then I start by going here, and I know this 8.2 is this angle right here. Given that, I'm going to do that for 192 miles, so this is 192. And then I'll go south, 68.5, we'll call it here, roughly for 207 miles. And the angle is 68.5 here. So let's just redraw this picture here and here. Again, I knew this was 8.2, so I know that in these two lines, these are alternate interior, so I know that there is a 8.2 degree marking here, and then a 68.5 marking here. I know we have 192 and 207. Altogether, this angle is going to be 76.7, and it's just a straight law cosine setup. So let's find x. X is equal to, I'm just going to do this all in one shot, square root 192 squared plus 207 squared minus 2 times 192 times 207 cosine 76.7.